Hey guys, it's Mrs. Conway. So I would like to go over the assignment, sorting equations and inequalities. So as I'm going over this, check your answers, fix them so that they are right, and at the end I want you to reflect on what you've learned through this video. So the first question here is asking you to look at this diagram and this equation and decide, is this always, sometimes, or never true? So we're thinking, will this always work? Is there some numbers we could put in for x that would make this work? Or is there no way that this would ever possibly work? So if we're looking at this, you could either think of this as plugging numbers in for x and y, or you can look at the shapes. Now I'm looking at the shapes and I'm seeing immediately right off the bat, these two shapes are not the same. This one has two black rectangles and two white rectangles, which altogether is a big rectangle, whereas this is just two rectangles. So they don't look the same, so they're probably not always true, because it would have to look exactly the same for it to be always true. Now, that means, is it sometimes or never true? Is there times when these would be the same? So let's look at this here. So we've got the piece that's not consistent is these 2's here. So this is a 2 by y, and this is a 2 by x. And here it's missing that chunk. So you kind of could think, well, x and y can change, right? If y was, say, 0, this would have no length. So if you had x was 0 and y was 0, looking at it in the equation, 0 plus 2 is 2, 0 plus 2 is 2, so you'd have 2 times 2, which is 4. And over on this side, you'd have 0 times 0, which is 0, plus 4, which is 4. So if I put 0 in, for x and 0 in for y, and let's make this bigger so we can see it better. If I put 0 in for x and I put 0 in for y, then this would work. Now, we already said it's not always true, and I found one time when it does work, which means it's not never true, which means it has to be sometimes true. So my thinking is that if I put 0 for x and 0 for y, then this will work. And so it's sometimes true. And for instance, if I put 1 for x and 1 for y, then I'd have 1 plus 2, which is 3, and 1 plus 2, which is 3. 3 times 3 is 9. And on the other side, 1 times 1 would be 1, plus 4 would be 5. So it's obviously not working. So let me just write down what I'm thinking here so you can see. So I'm thinking, looking at this equation, if I were to put 0 for x, so I'd have 0 plus 2 times 0 plus 2 equals 0 times 0 plus 4. Well, that would be 2, and that would be 2, and that would be just 4. Well, 2 times 2 is 4. So 0, if x is 0 and y is 0, it works. So on the other hand, though, if I put in a different number, I would have 1 plus 2. And let's use a different number for x and for y, because x and y could be the same number, but x and y could also be different numbers. So if I put 1 for x, and let's say I put 2 for y, then I'd have 1 times 2 plus 4, which would give me 3, and here I would have 3 times 4, which is 12. But here I would have 3, no, not 3, 1 times 2 is 2, plus 4, which is 6, which is not true. So it doesn't work. So if I have one that works and one that doesn't work, that automatically is sometimes true. So I found a point, or numbers that worked, really, and numbers that didn't. Okay, so you might want to think about what your thinking was. You probably were like, well, I can't think of anything that does work, so then you pick never. But you have to be careful, because just because you can't think of one that works doesn't mean there isn't one that works. So you have to be careful with that. Okay, next. This one, as you change x and y, can you find values that make it true? And which I think is what they're doing here. So if you slide these to make it so that the x and the y. Well, that's not changing x and y. What the heck? We can't change that number. There we go. That should be frozen. Well, anyway, if I change that and that, then I get... I think someone put the sliders in the wrong spot on that one. Let's go on. But yes, you can find one that makes it true when you put zeros in. Okay. So then what we're going to do is we're going to sort some cards. And it says to do it in groups. I encouraged you to get together outside of class if you could, but if you didn't, you should still be able to do this on your own. So we're going to sort into sometimes true, always true, and here's never true. Okay, so to do this, I'm going to look at these pieces one by one, and I'm honestly going to pull up some paper and I'm going to attempt to solve them. If I can solve it, then it's sometimes true. If I can't solve it, it's never true. And if I solve it and everything and get a totality or an identity, then it is always true. So let's look here at 2 times x plus 3 equals 2x minus 3. So it's 2x minus 3. Now, hopefully I shouldn't have to solve these all the way. So I'm going to start by distributing. That gives me 2x plus 6 equals 2x minus 3. I haven't finished solving this yet, but I'm starting to get an idea of what's going to happen because I have 2x on both sides. So first I need to get the x's on the same side, but that makes the x's go away. So I get 6 equals negative 3. That doesn't make sense. So this is a no solution. So that means that over here we should put it in never true. Okay. So let's look at another one. Let's do this one. Now, part of the problem with this one might be if it's been a while, you might have kind of forgotten your quadratic rules. You shouldn't perfectly need to have those because let's look at this. X plus 3 squared equals x cubed plus 3 squared. Hopefully you're looking at that and going, well, I know that's not always true because definitely this is not a property or a rule that works. You might FOIL this out, or you might just check some numbers that seem likely. 0 generally is going to be our number to try that might work when nothing else will work because it behaves so differently from other numbers. So let's try 0 and see what we get. So that gives me 3 squared and 3 squared because 0 to the third would be nothing. So I get 9 for both sides of the equation, which means that 0 works. So that means I either have a always true situation or a sometimes true situation. It's definitely not never true. And we just said we're pretty sure it's not always true, but to prove it, we could try a different number. And if it doesn't work, then we know for sure that it is only sometimes true. So let's try 1. 1 plus 3, squared equals 1 cubed plus 3 squared. That's going to be 4 squared. Is that the same thing as 1 plus 9? It's not. 16 is not 10. So 1 does not. So if 0 works and 1 does not, that means that this is only true some of the time. Okay, so we didn't actually have to solve it. With the quadratic ones on here, I'm going to encourage you to not try to solve them because we haven't really talked about that and it's been a while, and mostly think of it as evaluating. I mean, I'm pretty sure you can get away with that on this. So if at this point you're like, oh, I get this. I was just confused about what we were supposed to do. I want you to hit pause and I want you to try and finish this assignment on your own. And then you could even like skip through the video till you figure out if you make sure you did it right. If you're still a little confused, hang on. But if at any point you realize, okay, I'm kind of starting to get this, hit pause and finish it on your own. Because the more work you can do on your own, the more you're going to learn from it. But I also want to make sure that you're figuring out how to do it correctly. So I'm going to look at this one next. Another thing you could do is you could try this one, just one at a time. Say, okay, I'm going to see if I know where this one goes. Try it out while you hit pause, and then when you're done deciding what category it should go in, hit play again, and then you'll know if you did it right. Okay, so to look at this one, x over 6 equals 6 over x. I am going to do some algebraic manipulation here because fractions, make me nervous. So I'm going to multiply both sides by x so that I don't have an x in the denominator over here. Actually, yeah, let's do that, and then we'll see where that gets us. Those cancel, and then I could multiply both sides by 6, so I'd have x squared equals 36, which implies x equals plus or minus 6, right? Positive or negative 6. So we know there's some numbers that work. 6 would work. That's what this gets us. It also hopefully makes it obvious that it's not always going to be true. For instance, if I put 0 in, I would get 0 over undefined, and 0 would not work. There's a lot of numbers that wouldn't work, but I got some answers, so this is sometimes true. The majority of these are going to come out sometimes true because it's the most likely thing to happen. So let's look at this one right here because it's just right here. So 2 times x plus 3 equals 2x plus 6. Some of you might be going, oh, I know this one already. So if you think you know this one, put it in the category you think it should go in and then hit play and see if you got it right. So 2 times x plus 3 equals 2x plus 6. Well, when I distribute that, I get 2x plus 6 equals 2x plus 6. That's the same thing on both sides. That would be the same line on top of each other. So that is always true because it is basically just the same thing on both sides of the equal sign. All right, next one I want to look at is this one right here. So find that one, maybe hit pause, think about it on your own for a second before you hit play to see if you sorted it correctly. So I have x minus 6 squared equals 6 minus x squared. Now, again, we haven't really talked about quadratics. This is the thing where you'd have to use FOIL, and we haven't talked about that yet. I just want you to look at it from just a numbers perspective. This is not the same thing, right? X minus 6 is not the same thing as 6 minus x, so it's probably not always true. Is there a number we think might work? Again, my go-to is 0. Would 0 work? 0 minus 6, is that the same thing as 6 minus 0? And when I square it, because normally it wouldn't be the same. You'd get a negative and a positive, but this time you'd have negative 6 squared and 6 squared, which is positive 36 for both of them. So this is always not, this is not always true. This is true when x equals 0. Now, we have to figure out, would it work for whatever number we put in for x? Because of that whole squared thing, it might. So let's try a different number. Let's do 1 minus 6 squared. So that's going to be negative 5 squared, and that's going to be 5 squared. So you're going to get the same thing. We're going to get 25 on both sides of the equal sign because the squared kind of takes out the negative. What about a negative number? If you did negative 1, you'd end up with negative 7, which would squared, and you'd end up with 7 squared, which would both be positive 49. So you might be thinking, well, yeah, that's a lot of numbers, and hopefully you can start to see the pattern. Whatever's happening, I'm finding the difference, and I'm squaring it, and the squaring negates the negative. So it's looking to me like this is always true. Now, if you want proof, we could FOIL it out, and I'll just show you that really quick. Remind your brains what that looks like. That's where you write it out 2 times because it's squared. Then I would distribute x squared minus 6x minus 6x plus 36 on this side. This one would be 36 minus 6x minus 6x plus x squared. I remember I'm multiplying x squared minus 6x plus 36. That's where I'm getting those from. So this is going to be x squared minus 12x plus 36, and so is that, because you're going to combine those. So it does always work. It is the same thing on both sides. And hopefully you can see that through what's going on with the numbers, just to see we're taking the difference and squaring it. And so normally subtraction matters, but what it does is it just changes it, like x minus 6 is going to be the opposite of 6 minus x. And when you square it, the negative goes away. The negative is irrelevant. So this is always true. All right, this will be a perfect time to talk about x minus 6 and 6 minus x. We just said if we square it, it's true. Is it true if we don't? And I think we hopefully are all kind of going, well, yeah, it's not always true because we're not squaring it. But, for instance, if we did 0, actually 0 wouldn't even, I think 6 is the one that works for this one. Actually, no, this one we can just solve because this is linear. So I can add x to both sides. So that's 2x minus 6 equals 6. Add 6 to both sides. 2x equals 12. Divide 2. X equals 6. So if I put 6 in, 6 minus 6 is 0. 6 minus 6 is 0. 6 will work. But anything else is going to give us opposites, isn't it? X minus, or 3 minus 6 would be negative 3, and 6 minus 3 would be positive 3. So for this one, since we're not squaring it like we were in the last one, it's not always going to work. So it's only sometimes true. All right, take a look at x plus 6 over 2 equals x plus 3. This one looks like something I can solve. X equals x plus 3. I'm going to start by eliminating the 2 by multiplying both sides by 2. So I'll have x plus 6 equals 3x plus 6. Subtract 3x on both sides. You might decide to subtract x so you don't end up with a negative, but I like to always just get x on the left side. Subtract 6, so negative 2x equals 0, so x is going to be 0, which makes sense. That would be 6 over 2, which is 3. So if I got an answer, x equals 0, that means that it's sometimes true. Even though my answer is 0, it's only sometimes true. And again, you could imagine if I put 1 in for x, 1 plus 6 would be 7 over 2. 1 plus 3 would be 4, which is not the same thing. All right, 6 plus 2x equals 8x. Any guesses? Maybe you don't have to actually solve this one to get it. Maybe you're starting to get the pattern here of what's going on. Because I can tell you that this only has one solution. The reason I know that is because there's a different number of x's on both sides. So I can already kind of see, I'm looking ahead. If I subtract 2x on both sides, I'm going to be able to solve this. I got 1 for x, which means x is the only number that works, or 1 is the only number that works for x. If I put 0 in, I'd get 6 equals 0, which is not true. So this is sometimes true. All right, let's take a look at this one. X plus 1 times x plus 4 equals x squared plus 14. These ones are harder to tell right off the bat, right? Because they're quadratic. Now you could draw a picture. You're going to have x plus 1, and I'm going to try and draw my picture just a little bit like more accurate, because this side's going to be x plus 4. So if 1 is that far, then 4, wait, let's make the 1 a little smaller. Let's make 1 like that big. So if that's 1, 4 would be, and x squared plus 4 would be our x squared box, or plus 14. And it would have, 14 would be like 2 by 7. Anyway, this is going to have x squared plus some x. Oh yeah, it's going to have like 4x plus 1x. No, that's right. And then you've got plus 4 ones here, right? This x squared plus 14 is just going to have x squared, and then it's going to have 14 ones, whatever that looks like. So I don't see those as being the same. Now there might be situations where it does work. 0 wouldn't work. There's gotta be, I'm thinking there is one where this works. Just because, yeah, because this is gonna have like some x terms, so it's not everything's gonna cancel out, right? You're gonna have, this one's gonna be x squared plus 5x, 1, 2, 3, 4, 5x plus 4, and this one's x squared plus 14. So those cancel, so you have 5x plus 4 equals 14. So you end up with 5x equals 10, right, when you minus that 4 from both sides. So x would equal 2. So when you put 2 in, 2 plus 1 is 3. 2, so you'd end up with 3 times 2 plus 4 is 6 equals 2 squared plus 14. So that'd be 18. So when you put 2 in, it works. But visually, you can see it's not often going to work. And the only way that was the only way I could think to figure that. I guess you could have guessed and checked until you figured it out. So that is sometimes true. That one was a pretty hard one. All right, let's look at 3x squared equals 9x squared. Again, this is a sort of knowing your properties. Is 3x squared the same thing as 9x squared? When you square parentheses, you have to square both things inside, right? So 3 squared is 9 and x squared is x squared. So it does actually work. It is the same thing on both sides, which means this is always true. So that's right here. Okay, ooh, we're getting there. X squared plus 6 equals 0. That one looks, oh, I could solve that, but there's a trick. Right here, we have x squared plus 6 equals 0. Well, if we subtract 6 from both sides, x squared is negative 6. Can you take the square root of a negative number? Now, you guys have been through Algebra 3-4, so you know about imaginary numbers. But those are imaginary, not real. So in this context, we're going to consider this to be no solution. Because in this course, you're going to stay with real numbers. So all that stuff you learned about I is really cool, and you don't need it for this class, and you probably won't have to worry about them again. So if that freaked you out, then you can just say, I don't have to worry about those because I'm not a physicist. Physicists have to worry about that. Okay, so that's no solution, which means it's never true. Okay, imaginary numbers don't count. All right, x squared minus 1 equals x plus 1 times x minus 1. Now this one you might remember. Is that true? Is that a, one way to think of always true is that a property? Am I properly using my rules for algebra? And I don't know if, again, part of this would come down to remembering how to FOIL. So where you multiply x times x and x times 1. But this might also do if you remember difference of squares. So this is a rule that does work because you're going to multiply those and the middle terms will cancel out. But you could also just try some numbers. 1 squared, and it helps if you use numbers in order. So like negative 1 squared becomes positive 1 squared minus 1. It becomes positive 1 minus 1, which is 0. And that would be negative 1 plus 1, which becomes 0 times whatever is going to be 0. So if I put negative 1 in, that's what I get. If I put 0 in, 0 minus 1 is negative 1. This is going to be 1 and negative 1, so you'll get negative 1. So 0 works. Positive 1 is going to kind of do the same thing negative 1 did. So you'll have 1 plus 1 here, but then over here, you'll have 0. So 2 squared is 4, minus 1 is 3. That might be one to think about. If you put 2 in, you get 2 squared, which is 3. And then here you'd have 2 plus 1, which is 3, times 2. 2 is 3 on this side, 3 when you put it there, but then when you put 2 here, 2 minus 1 is 1. So you end up with 3 times 1, which is 3. What if I try 3? 3 squared is 9, minus 1 is 8. And then here I'd have 3 plus 1, which is 4, times 3 minus 1, which is 2, which is 8. So when you've tried that many numbers, And you might be starting to see the pattern of why this is working. You might start to see this always works. Or you can recognize that this is a difference of squares and it is a property that's being used properly. So this is always true. Okay, now we've got two variables, which can make things more difficult when we're doing this kind of problem. Only two left. I know this is a long video. Okay, now we have x plus 6 equals y plus 6. It's a lot harder for this to never work, to be honest, when you have two variables, because now I can put whatever I want for x and whatever I want from y. And right off the bat, I'm seeing if I put 0 for x and I put 0 for y, this works. So I found one that works. The question is, would this always work? Well, if it was the same variable right here, if this was both x's, then you would be very easy for you to say, yes, it always works. But since x and y don't have to be the same, I could put 1 for x, but then I could put 2 for y, which would mean that I would get 7 here and 8 here, which is not true. So the point, so really what I'm saying is 0, 0 works, but 1, 2 does not. So this is not always true. So when you have two variables, it's a lot harder to be always true. So this is sometimes true. This is true if you put 0 in for x and 0 in for y, or anytime you put the same number for x that you put for y, it would work, but it doesn't always work because there are ways that it doesn't work. And that's one of those things about the difference between always true and infinite solutions. You can have infinite solutions, but not have an always true situation. Because in that one, there's infinitely many numbers that work, but there's also infinitely many that don't work. Okay, last one. X squared equals 2x. And I think right off the bat, you're probably going, well, but it doesn't. So it's definitely not always true. But are there numbers that would work? Yes, in fact, I can think of two pretty quickly. 0 would work. If I put 0 for x and 0 for this x, I get 0 squared equals 2 times 0, which is 0 equals 0. So x could equal 0. And actually, x could equal 2 also, because 2 squared is 4, and 2 times 2 is also 4. So x could also equal 2. However, I don't think 1 would work. Let's test 1. 1 squared equals 2 times 1. That would be 1 equals 2, which is not true. So x does not equal 1. So this is... So now if you have been skimming through this, here is what your final answers should look like. For never true, you should have these two. 2 times x plus 3 and 2x minus 3. That's never going to work. They didn't use their distributive property, right? X squared plus 6 equals 0. Okay, for always true, you should have x minus 6 squared equals 6 minus x squared, and then the 3x squared in parentheses equals 9x squared. Then x squared minus 1 equals x plus 1 times x minus 1, and 2 times x plus 3 equals 2x plus 6. And then for sometimes true, you've got all those, and I'm not reading them all. You'll just have to look through and match yours and make sure they match. Of course, if you get these two right, then your sometimes true should be right, because that's all that's left. So next on Delta, I just want you to write a reflection of how you did on this, what you struggled with, questions you have, and fix any mistakes you made on your Desmos assignment. All right, thank you.